the next type of algorithms we'll be seeing as CART algorithms. So CART, so which is the acronym for classification and regression trees. Yes, this CART algorithm is sometimes known as decision trees also. So it is more often referred as decision trees. So the name of the model is decision tree because it looks an inverted tree. Okay, it will look like an inverted tree. The decision is made on the basis of some conditions, and splits are made accordingly. Okay, so again, maybe this graph would be this picture representation would give a more uh, insights about it. So basically, again, decision trees is a supervised learning techniques that can be used for both classification and regression problems. Yes, it can be used for regression problems also, but mostly it is preferred for classification problem. And also in this lecture, we'll be going with respect to that perspective itself. It is a tree structured classifier where internal nodes represent the features of data set. So basically here you can see smoker, drinker, weight are the features of the data set, and branch represents the decision rules. So you can see here the decision rules is like yes, no, or greater than or lesser than, and each leaf node represents the outcome. So the dark blue, what you can see in a node, is representing the outcomes. So in decision tree, there are usually two nodes, which are like kind of a decision node and the leaf node. Okay, so decision nodes are used to make decisions and have multiple branches. Okay, so it's just not limited with respect to two branches, but it can have multiple branches also over here. So the all the light blue, what we see is actually the, so basically those are the decision nodes, and also the dark blue as mentioned earlier are the leaf nodes. Okay, so so the leaf nodes are the outputs of those decisions and do not contain any further branches. So the decisions or the tests are performed on basis of basic features given the data set. So it is a graphical representation for getting all the possible solutions to a problem or a decision based on the given conditions. So it is called as decision tree because it is similar to a tree. So you can see from the top. So basically, the toppest node over here, what we have smoker, the initial first question or whatever is the conditional statement, decision node. So the first ever node would be known as root node, and further downs are like further downs are branches, and will construct like a tree. Okay. So again, it is often known as CART also. So for CART stands for classification and regression tree algorithm. So it is used for both kind of. So we'll be going with respect to uh, classification way. So what is the criteria for splitting? So we just saw in the earlier slide that S and no were the criteria, right? So it is directly telling. So what are the criteria for splitting? So the root node, the starting point is calculated using an information gain. The information gain is calculated in two ways. Okay, one is entropy and other one is Gini. So basically entropy is calculated in this way. So here it will be nothing but minus p. So p is nothing but probability multiplied with logarithmic of base 2. Okay, so that is base 2 of p minus q into logarithmic of base 2 of q. Okay, see, p is probability and q would be 1 minus p. So that is the other remaining the other probability, probability of other condition. Okay. So again, taking an example over here on the right hand side. So we have some kind of node. So we'll consider E1, E2, E3. So just here you can see a calculation with respect to E1. So basically here we have two positive, one negative. So two positives are our probability. So 2 divided by whole. So that is 2 plus 1. That is 3. So 2 by 3 logarithmic 2 to log to the base 2, 2 by 3. And here we have a typo. It is 1 divided by 3. Okay, so negative is 1, right? So 1 divided by 3 log of log again base 2 of 1 by 3. Similarly for E3 also can be calculated. We have 3 positives and 1 negative. So basically the whole is 4. So 3 by 4 minus 3 by 4 log 2 of 3 by 4 minus p minus q. So that is 1 minus 3 by 4. That is 1 by 4. So 1 by 4 into log 2 of 1 by 4. Okay, so ultimately you will be getting the entropy value calculation over there. and there are a few disadvantages when it comes to this. So basically, before discussing these disadvantages, I want to tell why we need to use decision trees. So there are various algorithms in machine learning. So the choosing the best algorithms for a given data set is a problem. The just beta set and problem is the main point of remembering while creating the machine learning model. Below, we have sorry, not below, we have two reasons why exactly we need decision trees. So usually decision tree mimic human thinking ability. So it is like yes or no, so very easy to understand. So it mimics human ability, and the logic behind the decision tree can be easily understood because it is like a tree structure. Okay, so in the earlier example, we had something like we are taking a decision whether he's a young guy or a old guy, whether based on his weight, whether he's a smoker or a drinker. Okay, so such those decisions can be taken, like based on those three easily decisions can be taken. And so the disadvantage is decision trees to the max depth tend to overfit. So basically, if you had to recall in the first image, it was like we had maybe we'll just go back and show the representation. So here you can see it is a smoker, then drinker, then weight, and maybe one of these, young or two. So you can see the levels. Okay, so this is the max level down. So basically, the max depth tends to overfit. So generally, this doesn't happen much. So basically, what exactly is overfit is when the model takes in the training values and fit perfectly and fails to perform on the test sets. Okay, so this is called as overfit. We say the model has overfit. So you can test it by checking the training and test sets accuracy. So even training set accuracy can be checked. So if the training set accuracy is higher than the test set, so it is like safe to say that the model has done overfit. Okay, and we have underfit also. So again, we'll be fitting the model with respect to training set and test set. So again, in the projects we'll learn. So underfit, when the data is unable to fit well, that is the accuracy is lower on both training sets and test set, then we can say it is like the model is underfit. So this is generally case when the model is are using very too simple for the data set. So if you are going with a very simple model like for regression, if you are going with linear regression, so at this scenario it might happen. So instead you can go with SVMs. Okay, so those are the disadvantages of taking decision trees. Again, you get the idea, right? So based on the examples, you can decide a model. So that is about decision trees. We'll continue more algorithms on the next session.